In Episode 1, titled Start Smart, How the CompTIA Data DA0-002 exam really works, the point is to understand what the test is actually trying to measure because that shapes how a serious learner prepares. The CompTIA Data credential is positioned as proof that a candidate can handle everyday data work with care, not just repeat terms from memory. That matters in cybersecurity and in many other fields because data decisions often become security decisions the moment data is shared, stored, or used to justify an action. A learner who understands the exam's intent tends to study with purpose, which reduces wasted time and increases confidence. The aim here is simple. Build a clear mental model of how the exam thinks, so practice starts matching the real scoring logic. The exam is organized to reflect a practical view of data work, where problems are solved end-to-end rather than as isolated trivia. Domains act like chapters in a job, where one set of skills sets up the next set, and weak links show up later as errors or confusion. One domain leans toward foundational ideas about data concepts and environments, while another centers on how data is collected, prepared, and shaped into something usable. Analysis and reporting show up as their own focus because interpreting results and communicating them responsibly is a distinct skill from cleaning a dataset. Governance is woven throughout because quality, privacy, and control are not optional add-ons when real organizations are involved. When these connections are understood, the exam stops feeling like separate topics and starts feeling like one continuous workflow. Blueprint objectives can read like abstract statements until they are translated into the kinds of tasks people actually do during a workday. A line about selecting a data source becomes the real decision of whether a relational database, a file export, a log feed, or an application programming interface, often spoken as API, is appropriate for the question and timeline. A line about preparation becomes the real work of reconciling identifiers, normalizing formats, handling missing values, and documenting assumptions so another analyst could reproduce the same result later. A line about analysis becomes the real step of choosing an approach that fits the data type and the decision being supported, such as comparing groups, spotting trends, or checking whether a relationship is meaningful. Reporting objectives become the real act of presenting results so that stakeholders understand both the message and the limits, rather than only seeing a pretty chart. When objectives are treated as job tasks, the learning becomes concrete and the exam becomes predictable. Many questions are written to test judgment more than memorization, which is why the best answer is often the best fit, not the most impressive sounding option. Judgment shows up when a STEM implies trade-offs, such as needing a fast answer versus needing a defensible answer, or needing a broad overview versus needing a deep explanation. A distractor can be technically correct in some world, but wrong for the world described in the STEM, and that is why context matters so much. This is also where professional maturity appears, because real analysts avoid unnecessary assumptions and choose methods that match the data and the decision. The exam rewards the same habit because it is checking whether the candidate can make a reasonable call with incomplete information. When a learner shifts from "what do I remember" to "what fits here," scores typically improve. Common traps often come from scope creep and hidden assumptions, both of which show up constantly in real projects. Scope creep appears when the STEM asks for a focused outcome, but an answer choice solves a larger or different problem that sounds smarter and therefore feels tempting. Hidden assumptions appear when a learner fills in missing details, such as assuming timestamps share the same time zone, assuming a field is unique, or assuming the data is complete and clean. These assumptions are dangerous because they feel natural, and the brain prefers a complete story, even when the stem is intentionally incomplete. The safest approach is to treat the stem as the only source of truth and to resist adding extra facts from personal experience. That restraint is not timid, it is professional, because it produces decisions that can be defended with evidence. A reliable reading habit starts with approaching the stem like a requirement statement rather than a narrative. The useful details are usually the question being asked, the constraints that limit what can be done, and the success condition that defines what good means in that situation. Constraints can be technical, like data volume or format, but they can also be organizational, like privacy expectations, audit needs, or a limited audience. Another key clue is the stage of work implied, such as acquisition, preparation, analysis, or reporting, because wrong answers often jump to a later stage too early. This kind of reading does not need to be slow, because it becomes fast once the learner knows what to look for. The goal is consistent interpretation, because consistent interpretation prevents most avoidable mistakes. Keyword cues can help when they point toward the intended skill, but they cause problems when they replace thinking. Words that signal urgency, like quickly or near real time, often steer towards simpler approaches that trade precision for speed. Words that signal control needs, like regulated, audit, or sensitive, often steer toward traceability, documented logic, and careful handling of access and disclosure. Words that describe data shape, like outliers, skew, duplicates, nulls, or categorical, often indicate what preparation or analysis is appropriate for the variable types involved. Words that describe the decision, like compare, trend, forecast, or segment, often signal the kind of reasoning being tested rather than a single named technique. Used well, these cues anchor attention on context without turning the question into a word-matching game. Fast summaries strengthen recall because they force the mind to compress a messy situation into a clean statement that can be repeated accurately. A good summary usually names the data, the decision, and the constraint expressed in plain language rather than specialized terms. Speaking that summary out loud is especially useful in audio-first learning because the ear catches gaps that silent reading can hide, such as missing the actual question or overlooking a constraint. This practice also mirrors professional communication, where an analyst is trusted when they can restate a problem clearly and describe what evidence supports a recommendation. The exam quietly rewards the same skill, because a learner who can restate the STEM correctly is far less likely to answer a different question than the one asked. Over time, summarizing becomes a stabilizer that keeps attention steady even when the STEM is dense. The exam's topics connect across databases, preparation, analysis, reporting, and governance, because those areas connect in real work, even when different teams own different steps. Database decisions affect performance and access patterns, which can determine whether a dataset can be pulled quickly enough to meet a deadline implied in a STEM. Preparation decisions affect analysis outcomes because cleaning choices, missing value handling, and identifier alignment directly change what the math and visuals will show. Reporting choices shape interpretation because a chart can clarify a trend or hide a problem depending on scale, aggregation, and labeling choices. Governance shapes everything around those steps because quality checks, privacy expectations, and retention controls limit what is acceptable and what is not. When a learner expects cross-links, it becomes normal for a question to begin in one domain and require awareness from another. A lightweight routine is the kind that can be repeated daily without relying on occasional bursts of energy. Short cycles work well because they combine exposure with decision practice, which is closer to what the exam measures than long reading sessions that feel productive but do not test judgment. Consistency matters more than intensity because data reasoning improves through repeated contact with common scenario patterns like messy identifiers, conflicting totals, or unclear stakeholder requirements. A sustainable routine also benefits from variety because the exam expects flexibility across data sources, data types, and reporting needs. In professional terms, this is similar to steady conditioning, where small effort, repeated often, produces durable skill. When study is designed to be easy to repeat, momentum becomes the advantage. Tracking weak areas works best when it is tied to specific moments of hesitation or confusion rather than a general feeling of being behind. Hesitation often signals that a decision rule is missing, such as when a learner is unsure whether a field should be treated as numeric or categorical. Confusion often signals that a concept is being held as a definition instead of as a usable idea, such as knowing a term like normalization without recognizing when inconsistent units are the true problem. Those signals are valuable because they appear before a wrong answer is selected, which means they show where reasoning breaks down under pressure. In real analysis work, the same moments happen when someone pauses because the data does not match expectations or because the constraint is unclear. When weak areas are tracked by these signals, study time becomes more targeted and less emotional. Overstudying edge cases is a common pitfall for strong learners because unusual scenarios feel interesting and can create the illusion of depth. The exam, however, is built to validate readiness for common responsibilities, so it leans toward broadly useful reasoning rather than rare exceptions. Edge cases are still valuable when they clarify a principle, like showing why an assumption fails or why a method has limits, but they are less valuable when they pull attention away from mainline patterns. Distractors often appeal to the learner who remembers a niche fact but misses a basic constraint in the stem. The most efficient preparation keeps the focus on what is most likely and most defensible given the information presented. That approach still respects complexity, but it spends effort where it pays off most. A repeatable approach for steady progress looks a lot like the workflow used by careful analysts in the workplace. The first step is interpreting the problem accurately, which means understanding what decision is being asked for and what success looks like in that context. The second step is noticing constraints and risks, including time, data quality, privacy, and the need for traceable reasoning. The third step is selecting an approach that matches the data and the decision, not just a method name that sounds familiar, and then checking whether the choice creates new assumptions that the STEM never supported. This approach works because it is stable across topics, whether the STEM is about data formats, statistics, visualization, or governance. As it becomes familiar, it reduces stress because each question starts to feel like the same kind of professional judgment call. To wrap up, the core idea is that high scores come from matching preparation to what the exam measures, and that measurement centers on applied, defensible reasoning. Episode 1. Start Smart. How the CompTIA Data DA0-002 exam really works frames the test as an evaluation of connected skills across the data lifecycle, supported by careful reading, context cues, and clear summaries. It also treats progress as something built through a sustainable routine that targets weak spots signaled by hesitation and confusion, while avoiding the time sink of rarely tested edge cases. One next action that fits this approach is to take a small set of practice items and, after each one, say aloud a single sentence that restates the STEM's decision and a single sentence that explains why the chosen answer fits the constraints. That single habit strengthens accuracy, improves recall, and builds the kind of judgment the exam is designed to recognize. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.